We're looking at 2-5 notes on inequalities and two variables. And the first thing we want to talk about is what a linear inequality is. A linear inequality is similar to a linear equation, but you're going to have an equality symbol. And we know our symbols less than or greater than. And we're talking about that. You would have open circles, or what we're doing today, we would have dashed lines. And if it's less than or equal to, greater than or equal to, it would be a closed circle. And for us, it would be a solid line today. And when you're dealing with a linear inequality in two variables, we are going to be doing them on a number line and shading. So given y is greater than or equal to negative 2x plus 9, I'm not asking you to solve this or to graph it. I'm just asking you to determine if the points satisfy the inequality, and you're just simply plugging in your x and y and seeing if it's true. So we would plug in the 4 is greater than or equal to negative 2 times x is 7 plus 9. Go ahead and crunch your numbers. We get negative 14 plus 9, which is negative 5. Is 4 greater than or equal to negative 5? Yes. So is this a solution? Absolutely. All right, go ahead and you can work on the next ones. All you're doing is plugging in the x and the y and evaluating it. So I get 3 plus 9, I get 12. Is 3 greater than or equal? Oh, not 12. What do I get? 11. Is 3 greater than or equal to 11? No. So is that going to satisfy the inequality? Absolutely not. So again, you're not asked to graph it. You're just asked to plug in the number, and this is your proof. Even if you're doing it in your head, you're going to write it out to show what you did. All right, I got negative 20 plus 9. That is a negative 11. Is negative 5 greater than or equal to negative 11? Yes, you have to think about your negative numbers, so that one is good. Okay, so let's talk about a problem here. John sells t-shirts. Plain shirts are $5 and graphic shirts cost $7. In order to match the product cost, he must make at least $1,200. That tells me it's an inequality because he wants at least $1,200. All right, write an inequality represent this situation. I need variables. Well, I know how much the t-shirt costs, right? And I know how much money he has to make. What don't I know? How many t-shirts? Yeah, if I knew how many t-shirts, I know how much money he's making. So I'm going to do P would equal the number of or amounts of plain t-shirts. And I'm going to do, what's the other one? Graphic. G is number of graphic t-shirts. Now, if you like to organize all your stuff, right beside this, you could put on here, hey, these are $5 and these are $7. And that's all the info that I need. My inequality would be $5 times the quantity, cost times quantity. That's all the money on plain shirts, plus 7G. That's all the money on graphic shirts. And the money said it has to be at least $1,200. So what symbol should that be? Greater than. The problem is we see least, so a lot of people think less than. At least, can it be $1,200? Yes, at least means $1,200 or more. Okay, now if I was graphing this, I probably would have used X and Y to help me with my graph. But since we're just doing a word problem, we use the P and the G to represent the actual items and the number of. He plans to sell 150 plain shirts and 60 graphics. Is he going to be able to cover the cost? I don't have to solve anything. I just have to plug in. The 150 is my P, and the 60 is my graphic. And I'm probably going to do a quick calculator on this and see what I get. So multiply, add them up. I believe it's 1170. And that is not going to work, is it? Okay. So that's not your answer. You do need to state. It says, will it be able to cover the cost? No. It is, or we can say, let's just do 1170 is not enough to cover costs. So write out your answer with some meaning, but this is your proof. You're going to show some work to show the proof. All right, if he sells 90 graphic shirts, what's the minimum order of plain shirts he must sell? Okay, We want the minimum number. So I am going to use that 1200 that we need, right? So 5 times P is what I need, plus 7 times 90. We need it to be greater than or equal to 1200. All right, so clean this up. You know that you can just do 7 times 9 and tack on the 0. Uh-oh, I lost my inequality. There it is. Subtract the 630. You get what, 570? Divide by 5. And I'm getting P is greater than or equal to. And honestly, you should be able to be sort of crunching these numbers and then just looking up to make sure that we agree on our numbers. I believe it should be 114. Okay, if you leave me this answer on a word problem, you won't get full credit. So what do you need to tell me? Yeah, he has to sell a minimum of 114. Which kind of shirts? Plain. Okay. So who is it? John? John must sell a minimum of 114 shirts. Oh, plain shirts, we said. To do what? What's it mean to break even? What? To break even means not to lose money, but he's not going to make money. So if he breaks even, that means anything in addition to that would be money for him. Okay, breaking even is basically not owing anything, but not making any money. Businesses don't want to break even. Obviously, they want to get a profit, but breaking even is better than being in the red, which is owing money. And then they can build from there. Okay, now if I just said how many shirts could he sell to make that, you would say 114 shirts or more. That is important, so pay attention to that. This said, what is the minimum? The minimum is 114 shirts. If I just said how many shirts does he need to sell, then it would be 114 shirts or more, because we're talking about an inequality. Okay, now we're going to change gears. Put the inequality in slope-intercept form. Be sure to flip the inequality if you multiply or divide by negative. What was slope-intercept form? Y equals mx plus b. That's the form we want it in. Graph dashed if it's less than or greater than. Graph solid if it's less than or equal to, greater than or equal to. So a line means a line. Shade above the line when the inequality is greater than or greater than or equal to. Shade below the line when less than or less than or equal to. There's no shading left and right because we're saying y is greater, y is less, and your y-axis is the up and down one. Okay. Now, you could also, for shading, you can also use a test point. If that helps you, you plug it in, see if it's true or false. So here we go. The first one, and remember, we always want y equals mx plus b unless you're told to use x and y intercepts, which we will still use x and y intercepts. The first one's already y equals, right? So what is m and what is b? Okay, so slope is -4 or -4/1. What's your y-intercept? And what number's added on? 0. Okay, so you're going to start on the y-axis at 0. You're going to, I'm going to go down 4, 1, 2, 3, 4, and I'm going to go right 1. Down 1, 2, 3, 4, right 1. You have to make sure that you go one negative and then one positive direction. All right, go ahead and sketch in dashed or solid. Solid line. And then we need to determine where to shade. Now, where it says y is greater than or equal to, we need to shade going up the line. So if you think about your y-intercept being your intersection, it says y is greater than. If I go up the y-axis, my numbers get greater. If I go down, my numbers get smaller. So it's not left or right, it's up or down. Now I'm going to show you a test point just as a quick reminder. The easiest test point to use is 0, 0. I can't use it if it's on my line, so let's just pick 1, 1. You don't have to use a test point unless you need it to check your shading. If I put 1 in there, is it greater than or equal to -4 times 1? Yes, 1 is greater than or equal to -4. So if my 1, 1 works, then everything gets shaded. If I picked a point down here, it'd be false, so I shade the opposite side. Okay, what form is number 2 given in? Do you remember the name of that form? This one's considered standard, right? The ax plus by equals c. So I need to solve for y. I'm going to subtract x, and I get -6y is less than, I'm going to put it in order, -x minus 12, but you don't have to. And then what am I doing now? Dividing by -6. Now, I prefer to divide each piece by -6 rather than one big fraction. That, I think, makes a difference, and it's y is greater than, right? We flip our inequality. This is really the same as saying 1/6x. There's a 1 in front of there, and then plus 2. All right, so my slope is 1/6, and my y-intercept is 2. So nothing new here. Same thing you did. The difference is we have inequalities. So start on the y-axis at +2. Go up 1 and then right 6, and I'm going to go the other way, -1, -6. If I have a positive slope, my line should be going uphill. Dashed or solid? Should be dashed. All right, so there is my line, and then let's read it. And you want to make sure that you don't go back to the original. It's not less than. R should be y is what? Greater. So as I go up the y-axis, my y values are getting greater. All right, go ahead and you start number 3, which is this problem. All right, first thing I'm going to do is I'm going to subtract 9x. So if it helps you to show it, write it down. I'm going to go in order. You don't have to, but I'm going to put the x first and then the -60 after. Okay, divide each piece by 12. Now, you want to keep everything as a fraction. No mixed numbers, no decimals. I didn't divide by negative, so I'm not flipping the sign. Y is going to stay greater than or equal to, but we're going to reduce it to -3/4 x minus 5. Okay, so slope is -3/4. Y-intercept is -5. Make sure you're on the y-axis, and then you're going to go down 3 and +4. It should be dropping, and if you want to check it out the other way, you would rise 3 and run left 4. Dash or solid on this one? Solid. And then determine where you're shading. It says, and remember, make sure you're checking your inequality. It says y is greater, so we're going to shade as we go up. Unfortunately, these have all been shading greater, but there could be some that be shading less than. Okay, go ahead and look at number 4. I can't solve this one for y. There is no y there. What's that mean? Show me with your hands. What kind of line is it? It is a vertical line. It is going to cut through the x-axis at -4. It will be dashed or solid? It will be dashed. What is the slope of this line? The slope should be undefined. Okay, slope will be undefined, and one easy way to remember is that it cuts through the x-axis at -4. Now this one is left to right because we're comparing x. X is less than, so we're going to be shading to the left. Now I know this is not on here, but let me just throw one more. On here. Let's do a second graph here of y equals 2. Tell me about that if I had y equals 2. It's going to be a horizontal line. The slope is 0, and the y-intercept is 2. So if I had y equals 2, let's say y is less than or equal to 2. Let's make that an inequality. I would have a horizontal solid line through 2, and since it says y is less than or equal to, I'd be shading everything below. Now, actually, when you graph two things on one graph, that'd be a system of inequalities. I just wanted to remind you that this would be your horizontal slope or horizontal line with a slope of 0, where if it's x equals, then it's your undefined slope with a vertical line. Cuts through the y-axis, cuts through the x-axis. Okay, go ahead and read your problem that is number 5. Still not enough. And this is where we're going to change gears a little bit. Okay, so we need to write our own problem and we need to define our variables. Because we're graphing it, I'm suggesting that you use your x and your y because it helps us to graph. Okay, so what are we thinking for inequality? You might not be writing it in slope-intercept form. You might be writing it in standard form. She spends 10 cents on each 3x5 and 25 cents on each 5x7. She's allowing herself $30. So that's her total. It's a limit of 30. That means more than 30 or less than 30? Less than. Can she spend 30? Yes, so less than or equal to 30. Okay, what I know the cost of each thing. What I don't know is how many. Okay, so X is going to be number or amounts of 10-cent prints, and I'm going to do it in dollars. And those are your 3x5s. And this is going to be the number of 25-cent prints, which are the 5x7s. I could have done it differently. I could have said number 5x7s, number 3x5s. But there's all my information. So it would be cost 10 cents times X plus cost 25 cents times Y. And we're comparing it to 30. And what symbol should I put in here? Less than or equal to, because she can't go over that limit. 30 is her max. So what she is spending is less than or equal to 30. Okay. I actually don't want slope-intercept form here. When we're doing word problems, a lot of times we're going to want to do X and Y intercepts. So I'm going to put a little note to myself. Word problems. A lot of times with word problems, it is better to use X and Y intercepts. Because sometimes the numbers aren't so nice and you're not able to start and have a nice slope because of how you're counting. So we're going to use X and Y intercepts. Now tell me what you know about the X intercept in general. I always want them as an ordered pair, and what's your fact? The Y is 0 because you're on the Y axis. And what do you know about your Y intercept? It's on the Y axis and the X is 0. So we're going to use that. We're going to plug it in. Guys, when I put the 0 in for Y, what happens to it? Doesn't it just cancel out? So that's gone. 10 cents times X is less than or equal to 30. Divide by 0.1. X is less than or equal to what? Remember, you're dividing by a decimal. So 300. Now, the point is 300, 0, but the inequality to me is important. I'm going to show you how you can work with that. Now, let's do our y-intercept. Plug it in. 10 times 0 plus 0.25 times y less than or equal to 30. Again, that wipes out. Divide by 0.25. Y is less than or equal to 120. Okay, now what's this actually mean before we graph it? This would be the maximum number, 300 3x5s and 120 5x7s. That is the max. If we put that in, that's going to cost her exactly $30. That's the max. But there's lots of combinations she could buy. So this is what I need to graph. Finding the X and Y intercepts helps me to know what to count by. So before I start, guys, I don't want to count by ones or twos. But I also don't want to count by 50s because then my graph's going to be too small. So I'm going to make each block worth 12.5 because I'm making each tick mark worth 25. So do you see each block is 12.5 and each tick mark is 25, 50, 75, 100. And then I'm just going to start filling in. Here's 150, here's 200. You want to label it all, you can, but I end up getting a little overwhelmed. So do you see that I'm showing every other after well? I'm going to do the same thing, 25, 50, 75, 100, and then I'm going to start jumping, 150, 200, and this guy would be 250. Again, you want to put them all in there, you can. What's missing from my graph before I even graph it? What would I be losing points for? I know I didn't graph it yet. I need my labels, my titles. So what did the X stand for? 3x5 prints. Number of 3x5. And what was my Y? Number of 5x7. Don't be the kid who said, whoa, I told you what X and Y were there. I didn't have to. You still have to label it, okay? All right, so let's graph it. I'm going to graph this point at 300, 0 on the x-axis. And then I'm going to graph this point at 0, 120. Okay, well, there's 100. Here's 125. So sort of right in there. And then I'm going to do my best line that I can. I can always get a ruler. Dashed or solid. Should be solid. I'm a little bit off. And where would I shade this? Well, here's the deal. I know it says less than up here, but you can't use that symbol because if this was a negative number, it would flip. But read what you wrote here. You wrote X had to be less than 300. So you would have been shading coming down this way. And you wrote Y is less than or equal to 120. You'd be coming down this way. So the shaded region should be right in here. Now, notice a couple things I'm going to be picky about. Notice my shading is only in the first quadrant, and I have no arrows going on into the other quadrants because I can't have negatives. My cost would be $0 or more. I'm not going to have negatives. That's why we only graphed in the first quadrant. That's why my graph ends at these intercepts. Okay, now, using your graph, give two possible combinations of pictures that they could print to stay within the budget. Guys, they could print 25 and 50. So 25 3x5s and 50 5x7s. Pick another answer. Anything in the shaded region or on the solid line. I'd probably stay away from the solid line since it's not perfectly accurate. Let's do 150 and 75. No, I think that's too high. 150 and 25. So 150 3" by 5" and 25 5x7s. Scott makes Scott makes $12 per hour babysitting and $8 per hour working in the grocery store. He needs to make at least $600 to buy a new computer. Okay, what's at least $600 mean? 600 or more, 600 or less? 600 or more. And can he make exactly 600? Yes. Okay. So I know how much money he makes for each thing, but how much total money he makes depends on how many hours. So don't forget you have to define your variables. X equals number of hours babysitting. And I'm just going to put this $12 here because it's all in one spot. And this is number of hours at grocery store. And that is $8. Okay, so the amount of money he makes times the hours. So if he works 10 hours, that'd be $120 plus $8 times hours. And you told me what he makes has to be greater than or equal to the $600. Okay, Again, you could solve this for y equals mx plus b, but when you're doing word problems, I'm asking you to do your x and y intercepts. It's going to give us a more accurate graph and an easier graph. So think about what you know. You know the y is 0. Here you know the x is 0. And you're going to plug it in. 12x plus 8 times 0. That wipes out. And x is greater than or equal to 60 divided by 12 is 5, so 50. That means he's got to work 50 hours or more babysitting. And then we're going to put the 0 in. So this would be if he only worked at the grocery store. If you think about it, that's what this would be. He's working 0 hours babysitting, so it's all grocery store. And you should get y is greater than or equal to 75. So if he works 50 or more hours babysitting, he doesn't have to work at the grocery store. He works 75 hours or more at the grocery store. He doesn't have to work babysitting. Or any combination of them. All right, what should we count by? I'm going to count each block by 5, but each tick marks 10. So do you see that it's really 5, 10, 15, 20, 30, 40. I really need to get to 50 and to 75 on my axes. So you can see what you need to count by for that. If it bothers you, I guess you could, finish it. So even intervals. Your x and y axes don't have to be the same, but you have to pay attention if you're using slope if they're not the same. Okay, label on the x-axis, this would be number of hours babysitting, number of hours. I'm just going to put store. I'm out of room, but that's still good. Okay, so graph your points. Remember, it was 50, 0, and 70, 0, 75. So we're going to graph these points. 2 points make a line. So 50, 0. And then we have to do 70. So here's 75. And connect them. Dashed or solid? Solid, okay. But if he had to make more than 600, then it would be dashed. And a lot of us look and say, oh, it's greater than. But again, if this was a minus sign, it would flip. So look at your final things. X had to be greater than or equal to 50 would be shading X to the right. Y is greater than or equal to 75 would shade up. So my shading is going to be above the line. Now, the other way to do that is to do a test point. Okay, final question. Using your graph, give 2 possible combinations. So when they say 2 possible combinations, I want 2 ordered pairs, but they need to be labeled, right? It's a word problem. So it could be, we could use the 50 and the 0. 50 hours babysitting. And 0 hours at grocery store. That's one option. Another option would be something like 70-20. 70 hours babysitting and 20 hours at grocery store. Okay, now before you move on, I just want you to think about this. Which job pays more? Babysitting by $4, right? So the more hours he babysits, the less over hours he has to work. But if he doesn't get a lot of babysitting, he's going to have to work more hours in the store in general because he's getting paid less. So combinations of higher numbers babysitting are going to give him less work hours and more money compared to grocery store.